What's up, Algebra 2 students? Learning guide? No. What is this? Study guide? No. It says test at the top. That's a lie, though. It's not a test. It's your review. It's your study guide, whatever you want to call it. It is practice problems to help you prepare for the test. So, problem number 1. We are given some information, and we want to graph a rational function and write an equation for it. So, let's see what we can do. Let's go ahead and do A. So we have a hole at x equals -5. I don't care which you do, write it first or draw the graph first. I think maybe it's just a preference as to which one you think is easier to do first. Let's go ahead and graph it first. I think that might be helpful. Or maybe let's just do them simultaneously. Okay, so let's draw some axes here for our graph. So the first thing we have is a hole at x equals -5. So 1, 2, 3, 4, 5. What I like to do when I'm showing that there's going to be a hole, before I know what the graph is really going to look like, put a little open circle on that tick mark right there. That was poorly done, but you get the idea. So maybe we'll start building this equation simultaneously. Y equals, it's a rational function, so we need a big old fraction bar. We have a hole at -5. And how do you get a hole? Well, if you have a hole, it means you have a common factor in the numerator and the denominator. So in the top, it means we need to have the same thing in the bottom. If it's happening at -5, that means we need an x plus 5 in the top and the bottom, because -5 makes those factors equal to 0. All right, next thing is we need a vertical asymptote at x equals -4. So we can dash that in right there. That's going to help us. And if we have a vertical asymptote, it means we have a factor of whatever it is in the bottom. If it's x minus 4, it needs to be x plus 4 as a factor. If -4 is the solution, then x plus 4 is the factor. It's a vertical asymptote, so it is in the bottom. Now the last thing we have is a horizontal asymptote at the x-axis. Well, guess what? This already accomplishes that, because when the degree of the denominator is larger than the degree of the numerator, your horizontal asymptote will occur at the x-axis at a y value of 0. So we've got it. Now let's just sketch everything in. Now, remember, the other name for a hole is a removable discontinuity. We call it that because we can remove it from the equation. So this thing is going to look exactly like 1 over x plus 4, with the exception that x cannot equal -5, the value of that hole, which means it's actually just your mama graph looking like that. And so we can sketch it in. So I can even make it a little accurate, give myself a little tick mark there and there. I can put a point there, and I can put my hole right there. And then I can sketch this thing in, because we know what this graph looks like. It's going to look something like that. And that's cool. We actually know what the y value of the hole should be based off of our understanding of the mama function 1 over x. So it should look like this. We've sketched the graph, we've written the equation, and I think we're good. Now, this is absolutely 100% not the only possible answer. There are infinitely many possible answers you could provide. This is just the simplest possible answer. It's the simplest equation and graph that gives us all of these features that we're requesting. So there you go.